Hey space fans, welcome to Time Pilgrimage. Today we're diving into the mind-blowing world of planetary spins. Did you know that some planets are spinning in ways that make your head spin? For example, let's talk about Venus. This scorching hot planet is often called Earth's twin because of its similar size. But don't be fooled, Venus is a rebel. While Earth spins on its axis from west to east, Venus decided to go against the grain and spin from east to west. That's right, it spins backwards. How cool is that? Now you might be asking, what exactly is planetary rotation? Well, it's pretty simple. Just like a basketball spinning on a player's finger, planets are constantly rotating or spinning around an invisible line called an axis. This spin is what causes day and night on Earth. But here's the catch. Not all planets spin the same way. Some are fast, some are slow, and some, like Uranus, are tilted on their side. Imagine a planet spinning like a rolling ball. That's Uranus for you. It's like it had a cosmic collision that knocked it off kilter. These strange spins aren't just random occurrences, they're like clues left behind, hinting at the chaotic and awe-inspiring events that shaped our solar system billions of years ago. So, what caused these planets to spin so weirdly? Were they born this way, or did something happen along the way? That's what we're going to uncover in this video. Get ready to uncover the secrets of planetary spins and unravel the mysteries of the cosmos. Let's journey together into the heart of our solar system and explore the forces that make it so fascinating. So, how did these planets end up spinning in the first place? Well, picture this. Billions of years ago, our solar system was just a giant swirling cloud of gas and dust. As this cloud collapsed, it started to spin faster and faster like a figure skater pulling in their arms. This spinning motion caused the cloud to flatten out into a disk, kind of like a cosmic pizza dough. Within this disk, particles of dust and gas began to clump together, forming larger and larger objects. These objects eventually grew into the planets we know and love today. And guess what? They inherited that initial spin from the swirling cloud that birthed them. It's like a cosmic dance passed down through generations. But hold on, the story doesn't end there. The early solar system was a chaotic place with planets and asteroids constantly bumping into each other. Imagine a cosmic billiards game, but with giant balls of rock and gas. These collisions were so powerful that they could have dramatically altered the spins of young planets. A massive impact could have knocked a planet off its axis, causing it to tilt or even spin in the opposite direction. It's like getting hit by a cosmic bowling ball. These collisions played a crucial role in shaping the unique spin characteristics of each planet. But collisions weren't the only factor influencing planetary spins. Gravity also played a major role. You see, every object in the universe exerts a gravitational pull on every other object. In our solar system, the sun's gravity is the most powerful force, and it has a significant influence on the planets orbiting around it. Think of it like a cosmic tug-of-war. The sun's gravity constantly tugs on the planets, trying to slow down or speed up their spins. Over billions of years, these gravitational interactions can have a profound impact on a planet's rotation. It's a slow and subtle dance, but it can lead to some pretty dramatic changes. Remember Venus, our rebellious neighbor that spins backwards? Scientists have been scratching their heads for decades trying to figure out why it's such a weirdo. One theory suggests that Venus might have been hit by a massive object early in its history. Imagine a cosmic bully slamming into Venus and knocking it off its feet. This impact could have been so powerful that it reversed Venus's spin direction entirely. It's like hitting rewind on a spinning top. Another theory proposes that Venus's thick atmosphere might be the culprit. Venus is known for its incredibly dense atmosphere, which is about 90 times thicker than Earth's. Now let's talk about Uranus, the planet that spins on its side like a cosmic rolling ball. Uranus's tilt is so extreme that its axis of rotation is almost parallel to its orbital plane. Imagine Earth spinning like a top and then suddenly tipping over on its side. That's Uranus for you. Scientists believe that Uranus's extreme tilt is most likely the result of a cataclysmic collision with a massive object early in its history. This impact could have been so powerful that it literally knocked Uranus on its side. It's like a cosmic game of marbles, but with planets instead of marbles. As a result of its extreme tilt, Uranus experiences some of the most extreme seasons in our solar system. While some planets spin quickly, Mars takes its sweet time. And when we say slow, we mean slow. While Earth completes one rotation in about 24 hours, Mars takes about 24.6 hours. You might think, wait, that's not that different from Earth. But considering Mars is much smaller than Earth, this slight difference is actually quite significant. Scientists believe that Mars's slower rotation might be related to its relatively weak magnetic field. Earth has a strong magnetic field that helps protect us from harmful radiation from the sun. This magnetic field is generated by the movement of molten iron in Earth's core. Mars, on the other hand, has a much weaker magnetic field, suggesting that its core is not as active. The weird and wonderful spins of planets in our solar system are a testament to the chaotic and dynamic nature of the universe. From Venus's backward spin to Uranus's extreme tilt, each planet has its own unique story to tell. While we've made great strides in understanding the forces that shape planetary spins, there are still many mysteries left to uncover. As we continue to explore our solar system and beyond, we're sure to encounter even more bizarre and fascinating examples of planetary rotation. These discoveries will not only deepen our understanding of the universe, but also challenge our assumptions about what's possible in the vast expanse of space. So, keep your eyes on the stars, folks, because the cosmos is full of surprises. Remember those cosmic billiards we talked about earlier? Well, scientists believe that giant impacts played a crucial role in shaping the spins of many planets, including our own Earth. Imagine a young Earth, still forming and finding its place in the solar system. Suddenly, a Mars-sized object comes hurtling towards it at an incredible speed. The impact is catastrophic, shaking Earth to its core and sending debris flying out into space. This impact, scientists believe, is what formed our moon. But it also had a profound impact on Earth's spin. The force of the collision tilted Earth's axis, giving us our seasons. These giant impacts were like cosmic reset buttons, capable of completely altering a planet's rotation and leaving behind lasting scars. While giant impacts were dramatic events, gravity has been quietly shaping the spins of planets for billions of years. It's a subtle but relentless force that can have a profound impact over time. Remember that cosmic tug-of-war we mentioned earlier? Well, the sun's gravity isn't the only force at play. Planets also exert gravitational pulls on each other, especially when they come close together in their orbits. These gravitational interactions can cause planets to speed up or slow down their spins and even tilt their axes slightly. It's like a slow cosmic dance, with planets constantly adjusting their movements in response to each other's gravity. Over billions of years, these subtle gravitational nudges can lead to significant changes in a planet's rotation. So, what's the most compelling explanation for why planets spin in weird ways? Well, it's not a simple answer. It's likely a combination of factors, including the initial conditions of the solar system, giant impacts, and ongoing gravitational interactions. Think of it like baking a cake. The final product depends on the ingredients you use, the order in which you mix them, and the temperature of the oven. Similarly, the unique spin of each planet is a result of a complex interplay of different factors that have shaped its evolution over billions of years. It's a cosmic puzzle, and scientists are still piecing together all the clues. As we continue to explore our solar system and beyond, we're constantly discovering new and surprising things about planetary spins. For example, we've recently discovered exoplanets, planets orbiting other stars, that have even weirder spins than anything in our own solar system. These discoveries challenge our understanding of how planets form and evolve, and they raise even more questions about the forces that shape planetary spins. But that's the beauty of science. Every answer leads to new questions, and the search for knowledge is an ongoing journey. So keep asking questions, keep exploring, and never stop being curious about the universe around us. We've seen how giant impacts and gravitational interactions have shaped the spins of planets in our solar system. But what's truly amazing is that this chaos has ultimately led to a kind of order. Think about it. Our solar system is relatively stable. The planets orbit the sun in predictable paths, and their spins, while unique, are also relatively consistent. This stability is a testament to the delicate balance of forces at play. It's like a giant cosmic clock, with each planet playing its part in keeping time. And while there have been some bumps along the way, literally in the case of giant impacts, the overall system has remained remarkably resilient. This order from chaos is a recurring theme in the universe. We see it in the formation of galaxies, the birth of stars, and even the evolution of life itself. So, how did our solar system go from a chaotic disk of gas and dust to the orderly system we see today? Well, it's a process that scientists call dynamical relaxation. Imagine a group of people randomly moving around in a room. At first, it's chaotic, with people bumping into each other and moving in different directions. But over time, they start to figure out how to move around each other without colliding. That's kind of what happened in the early solar system. The planets and other objects interacted with each other through their gravity, gradually adjusting their orbits and spins until they reached a more stable configuration. This process took millions, if not billions of years, but it eventually resulted in the relatively peaceful solar system we know and love today. The study of planetary spins is not just about understanding our own solar system, it's also about exploring the diversity of planetary systems in the universe. Thanks to powerful telescopes like Kepler and TESS, we've discovered thousands of exoplanets orbiting other stars. And guess what? Many of these exoplanets have even weirder and more extreme spins than anything we've seen in our own solar system. Some exoplanets, known as hot Jupiters, orbit so close to their stars that they're tidally locked, meaning they always show the same face to their star, just like our moon does to Earth. Other exoplanets have been found to have highly elliptical orbits, taking them very close to and then very far from their stars. These extreme orbits can lead to dramatic variations in temperature and other conditions on the planet's surface. By studying the spins of exoplanets, we can learn more about their formation histories, their internal structures, and even the possibility of life on other worlds. So, there you have it. We've journeyed from the backward spin of Venus to the tilted axis of Uranus, and we've explored the chaotic history and eventual order of our solar system. But this is just the beginning of our understanding of planetary spins. As we continue to explore the cosmos, we're sure to uncover even more surprises and mysteries. Who knows what weird and wonderful spins await us out there in the vast expanse of space? One thing's for sure, the universe is full of wonders, and the more we learn, the more we realize how much more there is to discover. We've journeyed through our solar system and beyond, uncovering the secrets of why planets spin in such weird and wonderful ways. From Venus's rebellious backwards rotation to Uranus's off-kilter tilt, each planet's spin tells a unique story about its formation and evolution. We've learned about the chaotic early days of our solar system, when giant impacts were like cosmic reset buttons, dramatically altering the spins of young planets. We've seen how gravity, that invisible force that shapes the cosmos, has been subtly but relentlessly influencing planetary spins for billions of years. And we've discovered that the diversity of planetary spins is not limited to our own solar system. With the discovery of thousands of exoplanets, we're finding even weirder and more extreme examples of planetary rotation, pushing the boundaries of our understanding. But the most important takeaway from our journey is this: the universe is full of surprises, and the more we learn, the more we realize how much more there is to discover. Every answer leads to new questions, and the search for knowledge is an ongoing adventure. So the next time you look up at the night sky, remember that those twinkling points of light are not just stars, but entire worlds, each with its own unique story to tell. And who knows what other secrets of planetary spin are waiting to be uncovered? The universe is a vast and mysterious place, and it's up to us to explore it and unravel its secrets. So, keep asking questions, keep looking up, and never stop being curious about the world around us. Thank you for watching Time Pilgrimage, and as always, please remember to subscribe and like. If there is a topic that you would like to explore, please drop a comment. And be sure to share your thoughts on these new breakthroughs in the comments section. Until next time, keep exploring.